Good morning everybody. In our last video we have discussed about differentiability, the basic concepts, differentiability of a function. Okay, today we shall take variety of examples on differentiability of a function. We already have done. If fx is mod x is not differentiable at x equal to 0. Now my question is, if I write fx is x mod x, then what shall you tell? Let us see. Differentiability at x equal to 0. Now what is left hand f dash 0? That is left hand derivative or LHD. We can write LHD. L f dash 0 लिखते हैं, LHD लिखते हैं, f dash 0 minus b लिखते हैं. What it is? Limit h tends to 0, f of 0 minus h minus f of 0 by minus h. You see what it is. It is limit h tends to 0, f of minus h. It is minus h mod of minus h by minus h. Am I right? Minus h cancelled. Mod of minus h is h. Okay. And f0 is 0. Limit h tends to 0. H it is 0. And what is f dash 0 plus? That is RHD. It is nothing but limit h tends, very simple, f of 0 plus h minus f of 0 by h. What it is? Limit h tends to 0, h mod h minus mod of 0 by h cancelled, and it is 0. LHD equal to RHD is equal to 0. Therefore f is differentiable at x equal to 0. And what is that f dash 0 derivative? It is 0. Okay. Now let us take some beautiful questions on differentiation of a function at a point or something like that. Okay. Now let us take this question, that is, check differentiability of fx is x mod x plus mod of x minus 1. Okay. Now just you mark, what is its domain? It is set of real numbers. Okay. Now we shall check the differentiability of that function fx is mod x plus mod of x minus 1. Now let us redefine this function. Remove this modulus. Now mark here. There is a easy technique to remove the modulus. Now this is 0 when x is 0. This term is 0 when x is 1. Okay. Now I divide a real number line into different parts. Okay. Now if I take a number bit more than 1, this is more than 1 part, between 0 and 1 part, this is less than 0 part. Okay. Now if I take a number which is more than 1, say 2, this one is plus. Modulus of a positive thing is itself. Okay. So the result is x minus 1. Here this is. Here this is also plus. Modulus of this is x. Okay. Q mod of 2 is 2. And these two are added. So it is 2x minus 1. If I take a number between 0 and 1, what shall I get? Say, I take half. Then mod of half is itself, it is x. This is negative, half minus 1. It is minus half. So when I take modulus, minus का plus कैसे करते हैं? We write another minus sign. So modulus of x minus 1 between 0 and 1 is with a minus sign. X minus 1, it is minus x plus 1. So we are going to add them. It is 1. And take a number which is less than 0. Say I take minus 1. What is mod of minus 1? It is plus 1. Just I am changing the sign. So it is minus x. Okay? Why minus x? Because modulus of a negative thing we find by multiplying another minus 1 with that. So this is when I take x is less than 0, it is a negative thing. Here mod x will be minus 1 multiplied with that thing. Then plus. This is equal plus or minus. If I take minus up or minus 1. This is minus. So in order to get its mod, I will have to multiply another minus 1. So it is minus x plus 1 minus 2x plus 1. Now from this I can write fx as, yes, when x is less than equal to 0, what I get? Minus 2x plus 1. If it is between 0 and 1, 0 less than x less than 1, it is 1. And when x is greater than equal to 1, it is 2x minus 1. We will check its differentiability. Now, obviously when x is less than 0, it is a polynomial whose derivative I can find. It is differentiable. And between 0 and 1, it is constant function. So, it is differentiable. Or if x is more than 1, it is a polynomial which is also differentiable. Now clearly f is differentiable for x is 0 and not equal to 0 and 1. Okay. Now for x equal to 0, what is LHD? F dash 0 minus. It is limit h tends to 0, f of 0 minus h minus f of 0 by h. What is f of 0? Just you look, put 0 here, 1. Okay. Now this is limit h tends to 0, 0 minus h less than 0. This one I shall use. So what shall I write? Minus 2 into minus h plus 1. F of 0 is 1 by minus h. This one is minus h. So what we got? It is limit h tends to 0, 1, 1 cancelled, 2h by minus h. The result is minus 2. Okay. And what is RHD? Limit h tends to 0, f of 0 plus h minus f of 0 by h. Okay. What is f of 0 plus h more than 0? The result is 1. And f0 is 1. This limit h tends to 0. Answer is 0. LHD not equal to RHD. That implies f is not differentiable at x equal to 0. Okay. Let us check at x equal to 1. Now, for x equal to 1, what is LHD? Limit h tends to 0, f of 1 minus h minus f of 1 by h. Then this is limit h tends to 0. If x is less than 1, 1 minus the value of fx is 1. It is 1, and f1 is also 1. It is 0. And what is RHD? Limit h tends to 0, f of 1 plus h minus f of 1 by h. Limit h tends to 0, 1 plus h. देखो 1 plus h, 1 से बड़ा, 2x minus 1. Okay, 2x minus 1. तो replace x by h, f of 1 plus h, replace x by 1 plus h, 2 into 1 plus h, minus 1 or plus 1? Minus 1 by, it is 2x minus 1, yes, by h. What you are getting? Limit h tends to 0, 1, 1 cancelled, 3, 1, 1, 2. Minus 2 plus 2. I will write 2 plus 2h minus 2 by h. So it is 2. LRSD is 2. LSD is 0. So LSD not equal to RHD. That implies f is not differentiable at x equal to what? 1. Okay. So we got that function is not differentiable at 0 and not differentiable at 1. Okay. Let us take a very typical question. Question number 24 of your exemplar, which is supposed to come in your exam. Given f is a function from R to R and that satisfies the relation f of x plus y is fx into fy, and it is also given f dash x is never 0, and also given it is differentiable at x equal to 0, and with f dash 0 is 2, and we will prove f dash x is 2 into fx. Okay, so from the given thing, just you see f of x plus y is fx into fy. Now you see, replace x and y by 0. So what we are getting? F of 0 plus 0 equal to f0 square. So f0 square minus f0 is 0. So f0 common, f0 minus 1, it is 0. But f0 is not equal to 0. Why? Given fx is not, here I did a mistake, fx is not 0. So obviously fx is not 0, so f0 is not 0. So that gives me f0 minus 1 is 0. That means f0 is 1. So we got f0 is 1. Over. Next thing is we are given f dash 0 is how much? It is 2. How I get f dash 0? Means it is differentiable at 0. The f dash 0 like 11. How you find? Limit h tends to 0. F of 0 plus h minus f of 0 by h. It is 2. Now, what is f of 0 plus h? It is f of h. Limit h tends to 0. F of h minus f0 to 1 hai, by minus 1 by h. It is 2 given. Now, what I want to find? To find f dash x. Now, what is my f dash x? It is limit h tends to 0. F of x plus h minus fx by h, and this is limit h tends to 0. What is my property? F of x plus h. It is fx into fh minus fx by h. Mark what it is. Limit h tends to 0. Fx common. Fh minus 1 by h. Fx is independent of h. So I can, it is a constant with respect to h. So I can take it out. Fx into limit h tends to 0. Fh minus 1 by h. So obviously it is fx into 2. It is 2fx. Proved? Okay. In our next video, we will take another one tremendous example.